question 15. 4 redox systems relevant to hydrogen oxygen fuel cells are shown below. Which statements are correct for an alkaline hydrogen oxygen fuel cells? Because we're talking about alkaline, we are not expecting to have high H pluses because that's acid. So therefore, the one with the H pluses will be a cancel out. They won't be required because we're talking about alkaline hydrogen oxygen fuel cells, and so we are only interested in these ones. Likewise, this will not be a correct one because again it's got H pluses in there, and so that leaves 2 and 3 to look at. So for 2, we need to work out the overall system. In the first one, we need to look at the electrode potential here. The one that is more positive would stay because this is what you call the standard reduction potential. When you're adding electron, that's a reduction and it is standard. Therefore, this reaction will stay compared to that one because this is more positive and that's more negative. If this one stays, that means that has to be reversed. So therefore, the electrode potential for this one will be positive because we're reversing this and we're reversing the reaction. So let's do that. Now that we've reversed this reaction here, reversed it, then the potential too will be reversed. So that will be positive now. But we need to compare the electron here and the electron here. This one is releasing the electron and that is taking the electron. So because this one is 2 electrons and this is 1, we need to times the whole thing by 2 to balance the electron out. Now that we've multiplied that by 2, this electron will now cancel that electron. And this OH here will cancel that 2OH here, will cancel. So that now cancel that one. One of these will cancel one of those. So that'll be, that we go, and we got left 1 here. You can now see that you're left with, I have O2 plus H2, and that gives you water. You see that I have O2 plus H2, that gives you water. What that meant is this is now correct, and that's correct. So therefore 2 is correct. Therefore 2 is correct. Now we need to work out 3. That says the potential is 1.23 volts, which what we now need to do is add that potential to that one. Remember, this is now reversed. You don't need to multiply by 2 just because you multiply those by 2. You use the same potential. You add 0.4 plus 0.83, and that gave 1.23 volts. So now you add 0.83 volts plus 0.4 volts, and that gave 1.23 volts, which means this is now correct. Remember, this is minus because you reverse this, that volts will be reversed. That's what we got here, and we add them together, and therefore this is correct. So the answer will be 2 and 3. So the answer will be C.